Okay, so let's start. My name is Yamin Chen, and I'm from OriginLab technical support team. And this afternoon, I'm going to talk about the advanced statistics in Origin. So before starting, I will just let you know that if you have any questions during the webinar, just put it in the Q&A panel, and my colleagues will help to answer the questions. And before the end of the webinar, we will send out a poll and asking for your feedback. So so let's begin. Before start, I will just mention a couple of places that you can go and to learn Origin in the statistics in case that you are the beginner of using Origin or you are not so familiar with the statistics capability in Origin. So first is the Learning Center. You can press the hotkey F11 to launch the dialog, or you can just go to the Help menu and click the Learning Center. And yeah, just wait a second for it to pop up. Okay, so on the left side, you just click the Analysis Samples tab, and on the right, you will see a drop-down list where you can select from different examples. So basically, if you just double-click one, and it will open an example. So what is nice about the Learning Center is every examples in the Learning Center, it has a very detailed steps to run the analysis, and it also has a very detailed background about the data. And some of them also has the interpretation of the result. Usually it also has a link which will link to the tutorial page of this particular analysis. Okay, let me go back. And the second way is the tutorial page. If you go to the help and the origin and then select the tutorial, it will launch the tutorial page. Let me just, okay. And just click statistics and it will give you more detailed instruction about running each statistics tool. Okay. And of course, you can also contact our technical support team, and we are happy to answer any of your questions. If you have any good ideas that you want to share us, you have proposals to about like an app of running certain statistic application, you can just let us know, and we can help look into it. Okay. Now let's see. So first is I'm going to talk where the statistical manual is. So basically, as you know that the menu item is dependent on the windows there you are open. So the statistics menu is only available when you have a worksheet activated. Okay. So once the worksheet workbook is activated, you will see the statistics menu. So there are a bunch of tools that you can select from. Okay, so other than the menu, the statistics tools from the menu, we also have a lot of apps. So apps is usually like we made those apps by the request from customers, and they ask for certain statistics tool, then we just make it into app. So you can click Find App here to open this App Center page. And yeah, right now the statistics is automatically put in the search entry. Then you will see a list of statistics tools where you can select from, and you can click the download button to download a certain app. And once it's downloaded, it will show on the app panel on the right side. So here are a couple of apps I pre-installed on Origin. Okay. Now let's go to our topics. So in this webinar, I'm going to talk several ANOVA tool and a couple of multivariate analysis tool like PCA clustering, discriminant analysis, and I'm also gonna cover survival analysis. But at the end, I'm going to talk about using Python to run a support vector machine classification. So we improved Python greatly in our upcoming Origin version 2021. And I will show you how you can take usage of the Python. And if you know some statistics tool is available in Python, then you can pass data from Origin to Python and run analysis and put the data back. And I will show you that at the end. Okay, let's go to our first example, one-way ANOVA. So here I have my data. So this is the data of the nitrogen absorption for 4 different plant species. Okay, so I have organized the data in 2 different formats. So this is the index format where the data is in one column and the group information is in another column. So this is the raw data format. So I have 4 groups of data in each column. So many of Origin's analysis tool, the statics tool, support these 2 types of data. I just mentioned it. Okay, so let's go to one-way ANOVA. So as we know, in order to run a one-way ANOVA, the data has to fulfill some assumptions. So the group population, the population of each group should follow a normal distribution. So I will just first to do a normal test of the data. And to do that, I'm going to click, just select statistics, and I'm going to the script, statistics, and the normal test. And I will just put the group column in here and the data column in the data range. Okay, and you can select a different test method, and then I'll just click OK. This is just a simple tool to test whether the group data is following a normal distribution. So the footnote here tells me that all 4 groups in the population is drawn from a normal distribution. Okay, it's good. Then I can go ahead with the normal with the one-way ANOVA analysis. So let me go to statistics, ANOVA, one-way ANOVA. Okay, so this tool supports 2 different data type, index and raw, as I said before. So I'm going to use the index data. Okay, so right now the data is from column B and the factor is from column A. Obviously, I have only one factor in this case. This factor has 4 levels. Okay. Okay, then I just go to main comparison tab. I'll choose some popular test method, Tukey, Bonferroni. And I will also want to test whether the variance within each group are the same between groups. This is also another assumption for a one-way ANOVA. And I also just want to calculate the actual power. Okay. And in the plots tab, I'm going to check the bar charts, box charts, in comparison plot. And let me click OK. And if I go to the one-way ANOVA result table, first we can just go check the overall ANOVA table. So it's the small p-values here tells me the population means are significantly different between the groups. And I can expand the main comparisons node. And here the significant marker tells me the plant 4 is significantly different from the other 3 plants, right? But there's no difference between 1, 2, and 3. Okay, and we can also check the variance test. And the footnote tells me there are not significant difference of the variance, okay, which also fulfill the requirements for one-way ANOVA. And the power, the calculated power tells me that the type 2 error is kind of small. in this case. So the power is very close to 1, okay? Also, we can check the box chart. The mean of plant 4 group is much lower than the other 3 plants, okay? But in order to, tell the statistical difference, we still have to check the test. Okay, then I bring up the mean comparison plot. Here we have this vertical line at the 0 point. So where the difference of plants is across this, is overlapping with this line, means that there are no difference. And again, for plant 4, the main difference between plant 4 and the other plants are far away from this 0 line. So indicates there are difference between them. Okay. I just want to simply mention that the ANOVA analysis tool also supplies unbalanced data. So if the number of samples of each group is different, you can still use this tool here. So if I purposely mask a couple of data points, and I can use this worksheet mini toolbar to mask the data, and you will see the operation, the lock icon become yellow, which means there's operation is pending. I can just click it and recalculate. And you will see the number of samples of each group changes, and the result is getting updated, okay? So if we if we look at this data, we have the data column, the factor column. If we also know that the measurement is repeated on each sample, so here we have an extra column which indicates the sample ID. Then we can use the repeated one-way ANOVA method. So I will just simply show you that go to statistics. We have one-way repeated ANOVA, and select the factor and the subject. We can assign a subject column as well. Okay, and it will give you the warning message that's because we have some missing values in the data. So these missing values, or the objects corresponding to these missing values, will be removed from the analysis. Okay. And we will also see the result. And so this is for one-way ANOVA and one-way repeated ANOVA. Let me go ahead to two-way ANOVA. So for two-way ANOVA, in this data, we have two factors, sex and male, female, diet type. So LV is strict vegetarians, LV is lacto-vegetarians, SAD is a standard American diet, and here is the measurement, which is the systolic blood pressure. So we want to check the impact on the systolic blood pressure with the two categories. Okay, so let me, for two-way ANOVA, we are also checking if there are interaction between the two factors. So let me bring up this tool, ANOVA. So the data is automatically selected, and I will choose factor 1 as sex, factor 2 as diet. So in this case, I'm checking the interactions box. Okay, can again look at the mean comparison and mean plot. I'm just check these boxes. Okay, just click OK. So again, if we go to this overall ANOVA table, and we can see the sex and the diet, the p-value is kind of small, which means the effect of these two factors are significant. But the interaction, the effect is low because due to a high p-value. So the interaction term can be removed from the model. And yeah, we can also check the mean plot for for the interaction plot. We can see like within each, for example, within the sex factor, how the different the different diode type will affect the mean value, and we can check whether the trend are the same. That will tells us whether there is a interaction term. Okay, but statistically, we still need to check the p-value to make the decision. Okay, so this is for the two-way ANOVA. Let's go to non-parametric matrix tests. So for non-parametric tests, so when the sample size is small, so and also when the assumption that the normal distribution is not satisfied, then we cannot use the one-way ANOVA. So in this case, we have to go to non-parametric analysis. So let me first bring up this page. So we have this nice page talking about the non-parametric tests. So you can check the comparison between the non-parametric and the parametric analysis. So like in which case you will use the non-parametric method, and in which case you will use a parametric case method. And it also shows you the flow chart to help you to make the decision. Okay. You'd better come and check and to see. And I'm also gonna just show you this stats advisor tool. So this is a tool that will help you to make the decision which analysis tool you choose. So by just asking you a couple of questions. So for example, in this case, I have this index data. So the measurement on one group and the group info in another group in another column. So I'm going to compare the mean of the two groups. So I will answer the questions here. So for example, compare means in this case. So what do you want to compare? So I'm going to compare means and medians, and the test assumed data are normally distributed. I will click no because in this case we know it's not normally distributed. And how many groups? In this case, we have one group. Or let's see, I have one group with two levels. Okay. And does the subject contain two treatments paired or not? We are not doing the paired test, so I just check no. Okay, it will give us these results. So in this case, I'm going to choose the main Winnie test. This is like the corresponding non-parametric method, like compared to the one-way ANOVA. Okay, so let me just click the open dialog button to open the tool. And again, you can select the group range from column A, the data range from column B, and you just just click OK to output the result. Okay, I can turn off this tool. And the blue footnote tells me there are no significant difference between the two groups. So here it gives us the statistics. So if you want to know more of the non-parametric test, in this case, it uses the rank instead of the numerical values of the measurement to build up the statistics. You can simply click this green lock and go back to the dialog and click this question mark. It will bring you to this help page, and you will find here the algorithms and where you can check more details of this tool. Okay. Yeah. Let me go to next example. PCA. So PCA stands for Principal Component Analysis. So the idea of PCA is that when you have multiple quantities, and you want to see whether you can reduce the number of quantities to describe the data. Okay, so when we do like a machine learning or do like classifications, we have like measured multiple variables. Some of the variables might have a collinearity between each other. So we need to use this tool to pre-process the data using a PCA. So we can first check the correlation between these variables. So we have this nice tool called the correlation plot, and you can use this plot to check the collinearity between its variables. So if I click preview and I just change this to ellipse. Yeah, my colleague Isha has explained in detail of this plot type this morning. So here I will just simply check whether they have like a strong correlation. So yeah, it definitely has a strong correlation, right? From just simply looking at this plot. Okay, so which means this data is a good candidate for PCA analysis. So let me first, let me just check this data. So it's like a food consumption of different areas in UK. So England, Wales, Scotland, North Ireland, and a bunch of foods. Okay. Let me launch the PCA tool. It's under multivariate analysis PCA. So here, the variables, I will select the 4 columns. And for the label, I'm just select the first label. And other things you can select from. And in this case, I'm just going to check the plots. I will show loading plots and the by plots. And yeah, I will just leave others as it is and click OK. So let's see what's the key information this report tells us. So from the eigenvalues of the correlation matrix, we can see how many principal components we need. So it tells me like the first principal components explains 97% of the variation of the data. So, but the second components only increase that to 99%. So it tells us only one principal component is necessary and also the scree plot tells us the same information. So we are looking at the sudden drop of this eigenvalues. So it dropped dramatically at the second principal component. So we only need the first one. Okay. Let me also bring up this spy plot. And we can see that the North Island is way up here, and Scotland, Wales, and England are tightly grouped. And if I move this, let me move this label a little bit, and we can see the fresh potatoes are quite like aligned with the North Island. So which means the people in North Island is consume the fresh potatoes. They like fresh potatoes, and this also tells us why this component is far away from the others. Okay, so we can simply go back to the data. So we know that fresh potatoes make a huge difference of the analysis. So what if we just mask this data? Sorry, I have to mask the entire row. Okay, again, the log turns yellow. I will just recalculate. Once I remove this observation, then the four areas are good separated. Okay. Let me jump to another more complete example. So this is another the protein consumption in Europe data. So each column is one food, and each row is one country in Europe. This is a very old data, just to let you know. And I'm going to select all the columns and then launch the PCA tool. Again, observation, I choose country, and the quantities to compute, just leave it as it is. So in yeah, let me just click OK. So in this case, the you will see the eigenvalues does not increase dramatically. It just increase slowly to 100, and we can take a closer look at the scree plot, and maybe we can tell there's a sudden drop at the principal component of 5. So we can just use the first 4 principal component to explain the data. Okay. If I open up the biplot, we can still get some information from here, and we can see that there are a bunch of countries like grouped in this area. So they all like consume a lot of red meat, eggs, white meat, and milk. And the Portugal, Spain, Greece, these are more like Mediterranean countries. They follow a different diet. They eat more fruits, vegetables, and fish. And other like Eastern Europe countries like Albania, Bulgaria, they're in their food list. They prefer cereals. Okay, so this also gives us some information of the data. Okay. Let's go to our next example, PC or Spectra. Here, now the worksheet is in a column list view. So if I click Control W, it will just bring it back and forth between normal view and this column list view, which is like a summarize of each column. Okay. So I can just jump to the results. So this is a tool. This tool is from an app. You have to download it from our website. So this is the principal component analysis for spectroscopy app. Okay, so this app is used to compare the spectrums. Okay, and we see that each spectrum belongs to different groups. So this is non-oil, and this spectrum is from olive oil, and also spectrums from mixed oil. Okay, so after we run this tool, we can again first check the scree plot, and we will tell that maybe there are sudden drop at principal number of 4. So we can use the first 3 as a principal component. And from the loading reference spectrum plot, we can tell at which time the variable is more important to the component, to the principal component. So like for example, for principal component 1 at time like around 6 and around maybe 7.5 is very important to build the principal or the first principal component. And for here, the time at 3 or at 7 is more important to create principal component number 2. Okay. And if we look at the biplot, and we can somehow tell that here the green dots corresponds to olive oil, and the red dots correspond to non-olive oil. They are sort of like separated in the principal component space. But for the mixed oils, they are sort of like overlapping with others. Okay. This is what we can, the information that we can get by running the PCA to reduce the number of variables, and that we can plot out the data in low dimension space and check their like the classification. Okay. Let me go to clustering. Okay, so here I have this data. Okay, the monthly temperature, January all the way to December, and from different countries in the United States. Let me, so in this example, I'm going to see if we can use the clustering analysis in Origin to see if the data can, or the variables or the observations can fall into clusters. So let me first select all the temperature number of data from each month, and go to statistics, multivariate analysis. So we have two cluster analysis methods, k-means and hierarchical cluster analysis. So I'm going to use this method. Okay, so in the dialog, I can check the observation to the city. And under settings, first I will just check the, I will look at the variables. So I will come back and look at the observations later. And go to the, here I'm going to set the number of clusters to be 5, which I happen to know the 5 cluster is appropriate. And go to the other settings you can select from. Okay, let me click OK. Let me just open up the dendrogram. Okay, let me bring up the font size. So we can see that these code months are properly grouped: January, February, and March, and the months not that cold in the second group, and the other more pleasant months: April, October, May, September, and the hot months. Okay, so the clustering tool here did a good job to separate the months based on their temperature. Okay. Another thing I'm going to show you is we also have this circular dendrogram. So this is a different configuration of dendrogram. Okay. Just to let you know that we have this option. Next, I'm going to, instead of cluster based on the months, I'm going to cluster based on the countries. Let me again select all these data and go to hierarchical cluster analysis. So under settings tab, this time I'm choosing observations. So last time I'm choosing variables. Okay, let me select number of clusters to be 5 as well. And one thing I'm going to do is in the output, I'm going to put the cluster membership into the same worksheet of the raw data. Okay, let me click OK. Okay, I just go back to the raw data, and you will see the cluster membership data is like appended to this worksheet. So let me visualize the data in a more interesting way. So I have the longitude and the latitude of each city. So I'm just plot the latitude against the longitude. So I make a scatter plot. So it's you can see it's almost the United States, the shape. Okay, and I'm going to color the data based on the group member column. Okay, so I use this mini toolbar to color map this data to just to select the cluster membership. Okay, click OK. So you will see the data is nicely colored, and I can use a different palette. Let me choose a maybe this weather temperature palette. Okay, this is more, it's better. So you can see like the cities to the south are hot, and the cities to the north the temperatures are low. And let me do more change. I can change the size a little bit. You can click this anti-alias button to make it the dot looks more smooth. Next, I'm going to put the United States map beneath these data points. Okay, so we have this nice app called Google Map Import. I just click this app. Then I will click this button here. It will use the XY scale range value here. So, and the graph can be shown in different view, like roadmap, terrain, or satellite. Let me choose satellite in this case. And I just click import as update, and you will see the map will be put as a background beneath that data points. Okay. Let me again to click this fit page to layer button to make it larger. Okay. So now you see that if we hover the mouse over the data point, it will tells us more information. So let me right click on this tooltip and go to preference. I can add the city name to the tooltip and also add the annual temperature. Okay, so it shows more information. Okay, so we can hover the data, hover the mouse where this is Massachusetts. It's where our OriginLab company is located. If you are curious about that, and we can also see there is some this point has a very low temperature, but among other high temperature cities. So this is because it's in a valley, right? You can clearly see. Okay. Okay, now this is the clustering tool. Hopefully it is helpful. So next we just check the survival analysis. So in this data, we have the cancer study. So we have 2 drugs, which is applied to the rats, and the results are different in column B. So the experiment is run in 60 hours. So here, so 0 means the rats died because not from carcinoma, and 1 is the rat is dead because of a carcinoma, and the 2 means after 16 hours the rat is still survived. And we want to use survival analysis to calculate the survival rate as a function of time. And in this case, we also want to check whether the 2 drugs have the same or different effects on curing the disease. Okay, let me select the column. Maybe not, just go to statistics and survival analysis, Kaplan-Meier estimator. I just use this method. In the time range, I will choose the first column, sensor range, the second column, and the group range. That's the drug 1 and the drug 2. So the third column. And in this case, the censoring variable, I'm just typing 0 and 1. So let me click OK. So this is the result sheet, and we can just directly check the survival function, and apparently the survival function as the survival rate as a function of time is different for 2 drugs, and you also detect this the sensor data is also plotted on the top. Okay. So this is a survival analysis tool, and I'm going to the next example on discriminant analysis. Okay, so here I have this standard iris Fisher data. I have 3 species, Setosa, and vesicola, and the virginica. Okay, and I have the parameters, the sepal length and the width, petal length and width. Okay, so in discriminant analysis, I want to use this tool to do classification. For example, I have this training data I measure this like 4 different parameters, and since this is a known data, I also know what species that it is corresponding to its parameters. Basically, the idea is I can use this data to train a classification model. So when like new parameters comes in, I can tell which species that that new measurement belongs to. Okay. Before start, I will just need your attention that there's a green icon here. This is a This is a data connector icon. So which tells us that this worksheet is connecting to either a data file or either some web data. So what that works is if the data source, so the data in the web page or the data in the other file is getting changed, this worksheet will detect it, and the data in the worksheet will get updated as well. So there is a linkage between the source of data and the worksheet. Okay, and I can just okay. I have to install this data the data connector app before I can run it. Okay. Now let's first see I plot out the data on this graph. So sepal width versus sepal length, and we can see that the setosa is quite distinct, but the versicolor and the virginica is kind of mixed up with each other. You can't distinguish them. And if I plot the other two parameters, with petal width and petal length, so it's more distincted and more separated. But there are still some mix here, right? And so I'm gonna use the petal width and the petal length to build the model. Let me first choose the petal length and petal width, and go to Discriminant Analysis tool. Here, the group of training data is the species. Let me choose species. And you can also do prediction. So if I check this box, I can select the new data, and it will do prediction, tell you which species that belongs to. But yeah, but here I'm not going to do that. And in the settings, you can check what you want. Then, so for example, the discriminant function, you can use a linear boundary or a quadratic boundary. Okay, I'm just go with the linear first, and other things like what statistics you want to look at, and the quantities you want to calculate. You can select multiple different options. Okay. Let me just first click OK. So first, let me go to the result page. So this is this result tells me the post probabilities of each observation belongs to different species. Okay, so these are very small numbers, but I can show that with a smaller number of digits. Let me go here, and for digits, I just set decimal places to 1, for example. Okay, so yeah, so here like 1 here means this is it's a well-defined species, and if we go down and we will see some overlap for like index 53, this is some mix. So there are also some probability that it can be assigned to other species. So like a more so here is a star means this is a misclassified. This is a versicolor, but it is assigned to other species in this case. Okay. Next thing I'm going to do is I want to check which which observation is misclassified by looking at the graph. Okay, so first of all, let me add a column here. Then I'm just copy this column to the input worksheet. I can click this hunt button to go back to the first sheet and select the last column. Okay, and I just click OK. So because this column has this, let me increase the width, has the information which one is misclassified. Okay, let me use this data highlighter tool. Okay, let me just choose this misclassified, and you will see the symbol on the graph is highlighted, so we know this point is misclassified. Okay, and we can choose the other ones. Okay, so I just simply mark those points which are misclassified. It's clearly they are in the boundary, right? Okay, another thing we can do is, so now we use a linear boundary to separate the different species. If I go back to this dialog and I can, okay, so before, sorry, before I do this, I'm going to show you this classic, the classic summary training data node. Yeah, here you can see the Setosa is 100% correctly classified, and the versicolor is 96%, and the Virginica is 92%, and the total error rate here shows it's 4%. Okay, so this is using the linear boundary. If I change the linear boundary to quadratic boundary, so the error rate is increased to the error is dropped to 2%. So it's a increase of accuracy of this analysis. Okay. Okay, so let's go to the support vector machine classification. Okay, so this example, I'm going to use the Python script. In Origin, we have the app to do support vector machine classifier, but I'm here just to show you this another possibility to pass data from Origin to Python and then run that this classification in Python, then bring the result data back into Origin. So in Origin 2021, we improved the Python capability a lot. So now I'm running in 2020B. Let me bring up the new version, the Origin. Okay, let me bring this 2021 Origin. Okay, so here is the Python code. What I'm going to do is I have this raw the raw data. I have two variables, and the group information is in column C. I'm going to use these data as the training data to build a SVM classifier, and then I use that fitted model to do prediction on new data. Okay, so to run Python code in 2021, you just simply go to connectivity, and here bring up the Python IDE in Code Builder. Let me then copy the code. Okay, I simply just paste the code here. Yeah, I'll just explain a little bit about the script. So in Origin 2021, we have this new package called Origin Pro, and you can use this package to do communication between Origin and Python. So I just import this package, then I find the worksheet. Let me, okay. So I find the worksheet with the name train. So this is this worksheet will be saved to this object. Then I just bring the data. So here the worksheet to list method is to bring the first column to x1, and then the second column to x2 and the third column to y. Then I use these data in Origin to build the model. Okay, so here I use these data to train the model. Okay, this is just a very simple, just 2 lines to train the model, right? Then I use I create some new data, new x1, new x2, and I just use that the model to build this decision function and predict the y value. Then at the end, I put these result data and pass them back to Origin. So again, in this case, I find another worksheet called predict. So this worksheet. Then I put the data back in. Okay. So to run this script is simple. I just click the run button. Yes. So you see the data is bring back in. Okay. And also create this nice plot. So the blue points and the red points are well classified, and the boundary lines are drawn on the graph, and the contour plot behind this data points are the decision function. Okay, so the decision function and the predict y. Okay, and we can also show this in a different way. Okay, so you see the different region of the classifications shown in the graph. So this is a example that you can combine the Python capability and the Origin's powerful graphing capability together, that you can do analysis in Python, then you go back to Origin to visualize the data. So this is just one usage of the Python in Origin. Just to let you know that this is for 2021, the upcoming version. But we already released the Origin 2021 beta 2 just a couple of days ago. So if you are interested in using Python, just send us email and we can send you a beta version. Okay, so I think this is the for today's webinar. And before you leave, I'm just want to let you know that to do a polling and give up some feedbacks. So I will stop for a couple of minutes, and you can still ask questions or fill out the poll sheet. Okay. Again, thank you for attending this webinar.